This is a lesson on heat capacity and just heat capacity. At a high temperature, the particles making up the substance are moving fast. At a low temperature, the particles move slow. Heat is defined as the flow of energy from fast-moving particles, or hot temperature, to slow-moving particles, or low temperature. The hot stuff starts with this much energy, the cool stuff starts with this much energy, and they meet in the middle someplace. Enthalpy is the total package. Enthalpy talks about heat and pressure change. If you squirt a canned air for cleaning out your computer stuff, you'll notice that the can gets cool. That's because it takes energy to expand the gas. Enthalpy we got to consider if we have a closed container. We're not going to do closed containers in chemistry. So what we're going to do is we're going to consider heat the same thing as enthalpy. Now, enthalpy is important, like internal combustion engines, where you need the expansion of the gas to make your car run. So heat is the same thing as enthalpy if we're open to the air. Plus, it eliminates a whole side of chemical reactions, mathematical equations to worry about using. The SI unit of heat is the joule, which is J, which is a very small amount, so oftentimes they'll do kilojoule or kJ. SI unit of heat is the joule. This is universal now. You can talk about energy. This is a unit of energy. So kinetic energy, kinetic energy, mechanical energy, thermal energy, nuclear energy, any type of energy is measured in joules. Back in the old day, there was units for everything else, but heat was measured in the calorie. Calorie was abbreviated CAL, which is the heat needed to raise 1 gram of water 1 degree Celsius. The nutritional calorie that you see on candy bars and wrappers, and you count calories, is the nutritional calorie, and that's a big C cal, which is really bad to do because you don't notice that, which I prefer is K cal, because you can see that K cal, which means it's 1,000 calories. Move this point over 3 spots. Heat capacity. Different substances absorb heat at different rates. You notice this in the summer with walking barefoot on pavement and walking barefoot on grass. So the pavement absorbs heat more. So different substances absorb heat at different rates. And it also depends upon their size. If you try to boil a small cup of water, it's going to take a lot less time to boil a big old kettle of water. And water, by the way, is exceptionally slow to heat up. It's difficult to change the temperature of water, which is why they say watch a pot never boils. More specific, the heat capacity is defined as the energy needed to raise an object 1 degree Celsius. Which is very inconvenient because you have to do an experiment for every object you want to find out. If you're going to use the same object over and over and over again, like you do in calorimetry, that would be okay. But since you're talking about individual objects, it's not very useful. Specific heat capacity is much more useful. Which is abbreviated C, by the way, is the energy needed to raise 1 gram of a substance at 1 degree Celsius. Water, the definition of a calorie is 1 gram of water. So 1 calorie is just also specific heat of water. Calculations. 4.18 joules is equal to 1 calorie. So if you convert from one to another, so if you have 10 calories, 1 calorie on the bottom, 4.18 on top, calories cancel, 41.8 joules. If you have 2.09 joules, or that the calories, 4.18, that's half joules, cancels, so that would be 0.5 calories. If you have kilojoules to kcals, the calories cancel out, so you can use 4.18 with joules and 1 for kcals, because 1,000 times bigger, they cancel out. But if you have something like 10 kcals, you got to convert that first to, if you want to go to joules, you have to convert kcals to joules first, and then you can go ahead and use the conversion factor, and you end up with a fairly large number, 4 zeros, 41800 joules. Heat change, the other mathematical formula you have is change in heat depends upon the mass of the object, the specific heat of the object, and the change in temperature of the object. If we convert this formula to labels, change in heat is always in joules, mass is in grams, The units of specific heat is joules per gram degree Celsius. And temperature change is degrees Celsius. If you notice, degrees Celsius cancels and the grams cancel, and you get joules equals joules. So if you have a problem where you have 4,000 joules is needed to raise some mass of water from 10 degrees Celsius to 60 degrees Celsius, maybe at 50 degrees Celsius. So you go through the equation and find out what things are. Joules, so it's 4,000 equals the mass. They don't give you grams and they ask for mass, so that's something to know. They don't tell you the specific heat of water, but that should be a number that you should memorize. It's 4.18. 4.18 joules per gram degree Celsius, because water takes 1 calorie, and 1 calorie is 4.18 joules. And temperature. Well, which of these two numbers do you use? Well, it's change in temperature, so you have to subtract. So 50 minus 10 is 40. Always subtract so that you get a positive number. It's not necessarily necessary to do that, but for us, we're not going to worry about whether you're gaining heat or losing heat, which would be the positive or negative sign. Divide both sides. 4.18 divided by 40, and then doing the math, you'll get the grams. So when you plug in the numbers, all you do is you look for what's missing in the variables, the labels, and then that's what you're trying to find. That ends this lesson on heat capacity.